So let's begin our presentation here today for our podcast, just in case we have bad weather. What I'm hoping that you get out of this presentation is that you will be to understand some very simple things. Being able to look at network cabling in a building and understand what we're looking at, create and even look at and understand the network diagrams, so that when you walk into a building, you can look at a diagram and say, okay, this is what they've got going on. Understand basic operating procedures, how we manage our inventory, labeling conventions. It's all too important. Standardize your documents. And as always, document. Well, the Telecommunications Industry Association and the Electronics Industry Association, the TIA-EIA, they have a standard called the 568 Commercial Building Wiring Standard, which is different than the wiring standard that we use for putting our wires together. This cabling standard that we're going to talk about is the 568 Commercial Building Standard C, and it's also known as their structured cabling. It tells us the best way that we're supposed to install our networking media, which means how do we install our cabling? When should we upgrade our cabling? No matter what kind of media that we're using, we need to understand what the speeds are going to be, what their capabilities are, and how we should always be planning for the future. We're going to have to set up our networks in what they call a hierarchical design. For those who don't understand what that is, it's usually coming in from a top-down approach. And in today's networks are pretty much all done on a star topology. This, what we're looking at here, is a standard networking diagram. Now, as we come in, okay, the ISP is over here, what we'll call the cloud. This is our Demarc. Okay, now the Demarc is our demarcation point. This is where the telecommunications company brings the line into us, and then from there it goes from their responsibility to our responsibility. Now, in the readings, you may have noticed that we call things the entrance facility. The entrance facility is not the lobby where you walked into the building. The entrance facility is where the telecommunication company has brought the data into us and then transfers the responsibility over to us. Now, you see here in this data diagram, we have two entrance facilities, okay? One here to Demarc and one at the IDF. Now, for the most part, the IDF, the MDF, the main distribution facility, is typically your entrance facility. And then from there, we branch off into intermediate distribution facilities called the IDFs, which are common for like wiring closets that we would have in each and every work area. The reason we would have a bunch of different IDFs is so that we can meet our main wiring limitations. So, for example, if this room over here is, say, 70 meters away, but then I have my cabling over here, I can't just run all my wiring over to here because I would pass my 100 meter cabling length. So what we do is we run a separate data room over here, a cable to here, and then from here we consolidate all this work area in these different buildings. Another diagram to look at, and something that's important to understand, is our main distribution facilities here on the floor. And according to the 568C commercial wiring code, we would then have another intermediate or IDF distribution facility on each and every floor. Okay. Data rooms, racks, and other equipment. Okay, this is just a vocab section of what we need to talk about. The entrance facility, as I mentioned, is where the network or the internet connects to the school or to your campus or to your business. The demarcation point is where the telecommunications servers service has handed off the responsibilities to us. The main distribution facility is a centralized point of where everything will then span out in that star formation. Data rooms are enclosed areas that hold our networking equipment, where, so for example, in the previous slide here, you'll see building B comes back to here, but it also has its own consolidation area of our cabling. Racks are literally physical components like we have in our classrooms. At the end of each set of desks, we have cabling racks. And in many cases, we usually have 2 or 4 post cabling racks, which we'll talk about later. And they literally hold our equipment, hold our switches, hold our punch downs. Okay? And then our patch panels is where the wire comes in, and then we organize our wire into these punch down panels, and we actually physically have to put our wires in the correct orders. Here's our standard star topology. As you can see, we actually have computers coming into the main distribution facility. Now, this would be considered an extended star if we took, say, this group of computers here on top and we branched it off and plugged it into the intermediate distribution facility. A lot of times we would call that an extended star. This is how of course, you would always want your wiring closets to look. It is very rare that they look this nice. If you are very fortunate to have this type of wiring closet, count your lucky stars. Now, what you see here, okay, is the front panel of our wiring closet. And this just really keeps everybody organized. We have our labels here to tell you what port goes where, and then your wires come nice and neat into this channel here, and they go out. But what you're not seeing is in the back of all this are cables coming in, and then there are actual physical punch downs in the back of those where we actually physically had to connect each and every one of our wires. Now, we will cover this much more detail in your CNT 140 class for those of you who are going to be CNT majors. Our data rooms, or racks, and the other equipment that we want to talk about would be, and we have what's called now today called a converged network. Now, converged network means that we have voice, we have data, we have video all on our one network, where we're used to just having standard data on our networks. So today, voice typically is coming into our wiring closet, and so we might find in there our voice over IP telephone equipment, which would cover our gateway, which is how we would leave our network to get out to the public branch exchange, and then other voice over IP endpoints. The IDF connections, where the different closets would come in, and then we would have them organized, saying, okay, closet B comes here, closet C comes here. And we might also have different work areas that might come into our main distribution area, or the different intermediate distribution areas. So it's just a way for us to organize and keep track of all the different equipment in our building. You could have thousands and thousands of wiring cables coming into each and every closet. A work area would be all of your computers, all of your printers, all of your nodes that are in a particular room, and they would all come back into a particular IDF or closet. The wall jacket literally is what it says. It is that plug in the wall where you plug your PC or your printer in. And there's just a graphical representation of how the voice over IP would come into play here. This is what you typically would have to look for, and this is what I was talking about earlier. As you can see, this is my workstation area over here, which connects over to my IDF. My IDF, for organizational purposes, comes over here to the MDF. There could be a number of different reasons why we're not bringing this connection here, just bringing all these wires across the line into the MDF. It could be too much of a distance, or we just don't want to have 1,000 wires coming into the one area, depending on how big my MDF is, or do I have all my voice coming in here? If this spans over 90 meters, I can't have all this coming in. So there's a lot of different variables that would come into play as why we would separate our IDFs and our MDFs and not have all the cables in the one building coming in. Okay. This is one of our more common types. The 568 standard requires that we bring in 2 cables to each outlet box. In this case here, you can see you have your data on the bottom, your voice up top. You'll see that your voice is an RJ11. RJ11 means that it's a smaller jack as opposed to the RJ45. And more common today, we will see this also being an RJ45 jack, and our voice and our data will typically come off the same line. Our common rack systems, as I mentioned earlier, we have a 2-post and a 4-post rack. The 4-post rack is for your larger equipment, and you will also see the ventilation here on the floor. In your 4-post racks, the air usually comes up through to keep all of our equipment nice and cool. On these racks here, you'll notice also that these are typically all bolted to the floor and will not move again. This over here on the side is to keep all of your wire management nice and neat. The different types of cabling that we want to talk about are patch cables. Patch cables are your standard straight through cable. You'll be making one of those for us during your semester. Patch cables are used to connect a computer, a printer, or a node to the wall jack. They are also used to connect the punch down to a switch, which gives you your connectivity. The horizontal cabling is what you would see running over your head in our classroom. And if we were to take a look when you're walking down the hallways and look up, and you will see cabling up top, the cabling that runs in the ceiling is also called your horizontal cabling. This is the cabling that runs from your wall jack to your IDF or your MDF. The backbone cabling is the cabling, can be cable or wireless, can be fiber or copper, doesn't matter. But the backbone cabling is the cable that typically runs from closet to closet. So for example, to go from the IDF to the MDF. These are your standard lengths that we want to talk about. We're only allowed to have typically 100 meters. Now, what we also want to notice in here is a slight discrepancy. In the 568C, based on the class that you're taking, in your Network Plus book, they're just saying 90 meters and 10 meters to get your 100 meters. They're not accounting for what we call your cross connects inside the data room, which is your switching cable. In more common, we would say that this guy right here is typically going to be 3 meters in length. This guy's going to be your 9 meters in length. And these guys in here are going to be 6 meters in the closet. It really doesn't matter as long as the cabling lengths here, here, and here do not exceed the 100 meters. After 100 meters, we will suffer from something called attenuation. Now, attenuation is the weakening of a signal over time and distance. So here we're looking at what they're saying is our more common UTP cabling installation, where they're taking it from the wall outlet here into a patch panel, and then a cross connect coming over to the patch panel to handle into our switches. This type of connection here, which is called our 110 block, is one of the types of installations that is really falling out of favor. The speeds do not allow us to maintain our gig speeds that we're looking for today. So we're looking more today that we use a 110 patch panel, and we're eliminating this cross connect here. We typically see this piece here when we're working more into our voice area. Different types of cabling that we want to understand and look at. PVC grade Cat 5e cabling. As you can see, the PVC grade is the thin sheathing here. It is a lower grade, and usually it can hit 1 gig, but typically it's good for about what we call fast Ethernet. which is 100 meg per second. This is just a graphic of an RJ45 connector, also called an 8-pin conductor. The plenum cable, as you can see, the plenum one here is thicker than the PVC. The plenum cabling is what we use when we're running our cable inside of ceilings. Now the ceiling, because it has airflow up top for what we call the return duct in our HVAC systems, which means we're always feeding it fresh air. So if there were a fire up in the ceiling and we had this PVC cabling running inside, the PVC burns hotter, faster, and more toxic than the plenum rated. This has a bit more of a fire resistance to it. So this is what you have to run according to building code in the ceilings. You are not to run this in the ceilings or any type of plenum chase. And then here we have our category 6 cabling. Category 6 cabling does, by default, will do 1 gigabit speeds. And as you can see, the twisting, we have more twists per foot if we compare it to the 2 Cat5. So there are more twists per foot. There are different levels of twist per foot. It's a higher grade copper inside, and it has a divider. Now this is done for a couple reasons. Okay? The cabling inside of here has to be twisted to prohibit the phenomenon or prevent the phenomenon of something we call crosstalk, which is the canceling of a signal. You see, when electricity goes down these wires, it creates a magnetic field. That magnetic field then destroys the data on its neighboring wire. So what we do is we twist the wires, and the frequency then changes and it cancels out the magnetic fields as opposed to canceling out the actual data itself. When we're running our cabling, we want to do something called a termination. Termination is when we physically put the wire inside of what we call a punch down. Now the punch down is 2 barbs of metal that we push the cable into. Now what that does then is it scrapes or displaces the plastic sheathing or rubber sheathing that's on the wire. It's called an IDC, insulation displacement connector. It exposes the cable so we have an electrical conduction between the punch down panel and the copper. When we are terminating, we do not want to leave more, okay? It says in 1 inch of exposed cable, we're going to change that to a 1/2 inch of exposed cable. The reason, or a 1/2 inch of exposed cable, but a 1 inch of exposed cable, but a 1/2 inch of untwist. Let me repeat that. 1 inch of exposed cable. Okay, when we say exposed cable, that doesn't mean we want the copper to be exposed. We never strip off the insulation. So 1 inch of exposed cabling outside of the sheathing, and we have to leave a 1/2 inch or less of twist going right up into the punch down. This will also help prevent something called near-end crosstalk. We do not want to exceed the cable's prescribed bend radius, which is typically we don't want to bend the wire more than having an 1.5 inches of bend in the cable. When we are done installing our cable, we will then use a continuity tester. There are 8 wires inside of our cable. We want to make sure when we plug the tester on one end and plug the other end of the tester on the other end of our cable, that all 8 wires match up perfectly. If one wire is bad, then we have to go and re-terminate our lines. When we say cinch the cables loosely, it's because we don't want to use wire ties and zip them super tight onto our cable. What a lot of people don't understand is that data runs, yes, it is a pulse of electricity, but it is also running on a specific frequency, which is how we measure our bandwidth. And frequency runs on the outside of the wire as opposed to running in the wire like electricity does. So if we cinch the wires too tight, you technically can choke out the frequency or choke out your data. Protect your cables. Don't lay them across the floor. People run their chairs over top of them, get them caught in the table legs, they step on them, and eventually you might end up with a break in the wire. What we need to understand is that the more we bend our copper cabling, the more brittle it will become. And avoid EMI, electromagnetic interference. The lighting in your classroom has those fluorescent tubes that runs on 240 volts. And you might not hear it with your human ear, but it makes an electrical noise. Now, electrical noise actually has a damaging effect to our data. And as I mentioned earlier, make sure that we're running platinum rated cabling. It is more expensive, but it sure beats having to tear it out later on. Depending on your cable, you might have to ground your cable, perhaps if you're using something called shielded twisted pair cabling. Always leave slack in your cable run. A lot of times we will call this a service loop. The slack in the cable run allows us, when we are terminating our wires at our outlets during the construction phase, that if we make a mistake, we can pull a little more wire out, re-terminate it, and we're good to go. Use cable management devices like a cable tray. These cable trays allow us to keep our wires more organized. Patch panels for termination. The RJ45 connector that we saw earlier is not designed to be used on solid copper cabling. It's meant to be used on stranded cable. The horizontal cabling that we use is a solid copper core. It is more rigid. Therefore, the more we bend it, the easier it would be to break. The cable that we use for our patch cables is what we call a stranded cable. The stranded cable is like speaker wire, where it's made up of small strands of wire that are twisted together. So when we use our crimper tools on our RJ45s, they literally knife into the wire, giving us good solid conduction. If we use the RJ45 on our horizontal cabling, the wire really would just then move to the side or bend, which could give us intermittent connectivity. And as always, document where all of your wires go, where they've been terminated, the path that they are taken, and it also says use color-coded cables for different purposes. Now, the standards vary differently, and they're really only suggestions, but more commonly you will find out that your horizontal cabling is made up of gray or blue cabling. And then the other different colors that we have, everything from green to purple to red to white and yellow, those cables colors are used for special purposes. For example, you might want to use white for your heating system and red for your cameras or security. So make sure that you document what color goes where, and then also document each end of the wire. Label each end of the wire, so I know that room 22 on floor 3 goes to the wiring closet of floor 3 in, say, down the hallway. And then when I have 100 wires down there and I'm punching them down, I can make sure they all go to where they're supposed to go, and I can keep them organized that way. Your data rooms are often serviced by an HVAC system. The reason? We want to keep them cool. The enemy of your data network may be heat and also humidity. We want to make sure that the humidity levels and the temperature controls are adequate. If the humidity level is too high, we can form condensation on our equipment, thus causing shortages in our networking. And every data room should also be locked down. The easiest way to keep somebody out of your network is to literally lock the door. So security cameras are often suggested to be put maybe inside or outside, so that we can say who was in here. Once again, up-to-date detailed documentation. I try to make it a common practice that when I work on one of my customers' networks, that I always write down what I did that week or any specific changes that I had done, because who knows, I could get hit by a bus tomorrow, and then one of you might have to come in to replace me, and it would be nice if there was a little book or something, a little file somewhere that was telling you what I had been doing on that network, what I had done, so that you're not just scrounging around trying to figure out what the heck is going on. It makes everybody else's efforts on working on your networks much easier to work with. Network diagrams. a graphical representation of a network of networks, devices, and connections. I cannot express to you how important this is. What I prefer to do if I have the documentation at my disposal, I like to use the building's blueprints and then map out where my wiring closets are, and then map out the path that my wires have taken to get from point A to point B. You can also use programs like Nmap and ZenMap, which allow you to bring up a graphic representation. Your computer will go out and find all the network devices that are currently on, and then it's up to you. Then you can drag them around and organize them on your map. Cisco has set the standards of what a router graphic looks like, what a switch graphic looks like. So all networks out there all are using the same type of graphic representations. There's this graphic representation of using a program called Nmap, and all we're trying to do here is locate any information that we can about a particular node. Okay. ZenMap goes out and finds all the devices on the network here. So here we're looking for anyone from 192.168.2.1 all the way to 254. It finds all those nodes and it tells you everything that's going on with them. So it shows you here on 2.1 that it has OpenSSH running, Open Domain, Open HTTP. These are the ports that are currently running on it. This gives you some information about the nodes that are currently running on your network. You will find out that if you just try to run ZenMap or Nmap on your company's network, that you might get some of your network administrators a bit upset because they'll think someone's trying to hack and discover what's going on in their network. Okay. Here you can see some of the symbols that I was talking about. These are the common network symbols that Cisco uses that all networkers need to identify. Wireless access point, which is nothing more than a wireless switch. Okay, here's your switch. Laptop, web server, you can see it's got a little globe here on the side. File server, printer, workstation, common symbol for a router, and a common symbol for a firewall, and the internet has always been and always will be the cloud. Sometimes you might get a gateway device like this one here, like a router, that'll have the bricks of a firewall built right into it. That would typically be your gateway devices. Network diagrams give you an idea of how your network is typically set up. Now we will have physical topologies and logical topologies. Physical topology is more like this guy right here, just showing you what's where and doesn't really give you any other information other than the basics, as opposed to a logical topology, which tells you all the intelligent information about it, which is, oh, this is a Cisco ISR 4200 series router with IP addressing of 192.168.1.0/24. And that would be the logical information that we would have to digest. Wiring schematics, graphic representation of a network's infrastructure. How do I have it cabled? I prefer to use a blueprint, an actual blueprint for that. A rack diagram is your saving grace. Be able to walk into a network closet, look and see that there's 500 wires going in here, and you have to find the one lone wire that's not working. If you have a rack diagram to show you exactly where the wires is, your life is going to be so much easier. So if your current networks are not labeled in that manner and your rack systems are not diagrammed out for you, that would be a nice project for you to do on a day where you're not being nailed with a ton of work. This is closer to a more of a logical map. Doesn't have the exact specifics of what kind of devices we have, but at least it's telling you, okay, maybe perhaps this is building one over here. It's kind of just telling you exactly how you have your entire network set up, and then this guy here is what takes me out to the internet. Okay. Here's an example of a rack diagram, the devices that are installed on the rack, and these would be your patch panels here that you would label. You'll physically put your labels on here, but then you would also typically have another sheet over on the left-hand side for you to look at. Because once this is all wired up, it's going to be difficult for you to actually see your labels because of all the actual cabling that would be literally in front of the label. Essential documentation that you need to keep on your network, okay, would be logical and physical connections on the network. Not only do I keep documentation of the logical information on my network, but I will also take labels, for example, and put it on the face of my router, because your ports on your router are usually in the back. So I'll put the label on the face of my router saying, okay, my G001 port is connected to the outside at 10.1.1.1, and my G001 port is 192.168.1.250 is my gateway. Okay, that type of information I want to keep on hand. Inventory management is also critical as well. There are a lot of times in your organization you're going to be recycling equipment, and so you want to keep a note of the machines and devices that you have pulled out of your network and then what you have replaced in there. Also take a look at your address utilization. Computer networks are able to communicate with each other by the use of IP addresses, like the 192.168.100.1, 192.168.100.2. You want to, especially for your servers and your printers, keep track of those that you statically assign and keep track of those that you may dole out via DHCP. Vendors come and go like the wind, so you can say I bought this router here from CDW. The reason it's important that I know it came from CDW is maybe it's under warranty. Maybe I have a smart contract with them for Cisco, whatever. Who's allowed to work on my equipment, policies, and standards. That information all would go into a document. Please understand that policies do not determine how devices are set up. Policies are used to determine who can do what on a network, who will be responding to, say, an incident on my network. As I just mentioned, system life cycles. It's a matter of determining like how long devices will stay in line, in-house, how long they'll be active. You will find out that your networking equipment will be online longer than, say, a host. You might be replacing a PC every 3 years, but you might replace a switch every 6-7 years, only based on particular requirements or actual failed equipment. Inventory management, and I will add this to this as well. I do prefer a method of inventory standardization. So what I mean by that is, if we are going to be like here in our computer lab at Hack, if we are going to be a Dell shop, I mean all of our host PCs are going to be manufactured by Dell, then we will all stick with Dell. We will all stick with the same hardware of Dell. Or if we're going to be an HP shop, standardization is the key. It just makes your life as a network administrator much easier. Next, I want to discuss labeling and naming conventions. And this is important because it keeps track, or allows you as a network administrator to look at a label on your patch panel and say, oh, well, this port here is on the 3rd floor in room 205, and we have 6 of them. Because you might have 3-205-1, 3-205-2, -3, -4, -5, -6, before it goes to 3-206 to the next room 206. So try to keep some type of what we call naming convention. And think about, as a student here at Hack, that we have a series of naming conventions. You have your student IDs. Okay, if you were to ask somebody who enrolled shortly with you or the same year, you notice that part of your user IDs are all the same. Maybe your place at work, your M. Stevens for first name Mark, last name Stevens. Or maybe you go Stevens M. Either way, everybody has the exact same naming convention, something for us to follow. So here, as you can see, we have our ports, okay? And there's different ways to look at it too. Like on our routers, we have different slots. So this is my 0 slot, my 1 slot, okay? Or actually, over here, 0 slot, 1, 2. And typically, if you would take a good snapshot of it, most cases, right here would be the power supply. And then closer to the side of their power supply, Cisco typically goes from 0 on over to the right, and it'll also go up and down for 1 and 0, 1 and 2 on the sides here as well. And here you can see label and naming conventions on our cabling as well. And as you can see, as we get more and more wires in place, the labels are going to get more and more difficult to read. I do not recommend what they're doing here by putting a label on these cables, because as you can see, they're already falling off. Labeling here, and if you're going to label the cable, I would suggest that you label the cable here on the jacket and have it go around the jacket so it has something better to adhere to. Okay. Just standard business documents when you get a request for your company to do something called an RFP. Documents that are used just so to make sure that everybody understands what we're going to be going into is a memorandum of understanding, and then the detailed work that is going to be done is your statement of work. That is all written in your book as well. Service level agreements are part of the contract. A master service agreement defines the terms of future contracts between the parties, and most importantly, payment. Okay, and then your master's license agreement, which we can all look at in our books. Okay. Change management. Deal with this one all the time. You're setting up a network for a company, and you agreed that this is going to be the work that you were going to do based on your master service level agreements, okay? And then you're doing all this work, and then they come in and say, oh, we need this done, and this done. Well, that's all well and fine. That's an added price, folks, okay? And making change, the whole point is to not have a ton of changes. So good planning will prevent all these changes from occurring. But not everything always goes as planned. So it is important when you create your agreements that you have what's also called assumptions. Okay, the assumptions the assumption is that the holes in the walls that we have to go through have already been put in, so we can just run our cables through them. An assumption would be that when we go into the building, the ceiling grid will already be down, so that we don't have to tear down ceiling grid. Think of the amount of added extra cost if you have to work inside of a ceiling that is already up. Another thing you want to look at as a network administrator, and then when we're looking at our networking equipment, whether it be for Windows servers, Linux servers, or even our routers and switches, is software patches as well, because they could cause a great deal of problems. Not just to your time frame, but when we run patches on software and we don't test those patches first, it could end up hindering software that our users are currently running. Now, different types of software that we have to look at when we're doing changes, okay? A patch is a correction, improvement, or enhancement, okay? So we discover that there is a flaw in the software, we have to fix it. If we have large enhancements, okay, to our software, would be considered an upgrade. And then when we decided that we ran this upgrade, we ran this patch and it didn't work all that well, we would then have to run a rollback to make sure that our customers can keep using the software and work, because employees that are not working is a huge loss in money. So whenever possible, before running upgrades or patches, whenever possible, run those patches and upgrades in a test environment. Make sure it works for all parties, and then and only then should you run a huge push of all your upgrades and patches. Same change management principles apply to any type of change, okay? Make sure that your boss approves it. Make sure everything's been approved. Say, hey, I'm going to be bringing the internet down tomorrow at 3:30. Everybody out of the building. I'll be upgrading the Exchange server, stuff like that. You want to minimize negative impact for your customer. Remember, loss of time is loss of money, and when money gets lost, there's always somebody who's willing to point a finger, and you do not need that finger to be pointed at you. Anything you do, as with whether it was cabling, whether it was a patch, whether it was an upgrade to the system, make sure that you document. Okay. And if need be, have an employer, have a person, management in your company, have them sign off on all changes. This way they just don't come to me and say, oh, well, Bridgehouse did this and that's why it doesn't work. Well, if it was approved to have happened, then at least if something does go wrong, it doesn't always fall back on your lap. Organizations tend to follow a single cabling standard. Around our area, we have our TIA, EIA 568 commercial building standard, and our cabling always gets wired in a 568B. Network begins at the end and ends. Begins at the Demarc and ends the workstation, period, the end. Whether it has to go through the MDF, the IDF to get to where it needs to go, that is how networks run. Okay. Horizontal cabling, as I mentioned earlier, is the stuff that typically runs in the ceiling. So it's what goes from the work area or the workstation all the way to the IDF, to the patch panel. Okay. Backbone cables consist of the wire, the cable or the link that goes from the IDF to the MDF, what connects our closets to our closets. Okay. Please be sure that your data rooms are serviced adequately by the HVAC systems. That humidity level and temperatures are controlled properly. Better to have your control room too cold than too hot. Okay. Network diagrams are going to be your saving grace. You might work on a building for a full year, and then 3 years later you come back to that building and you're expected to remember how you have it cabled. It's probably not going to happen. But if you have a network diagram or a map demonstrating your work and layout, you're going to be grateful that you did your work. Naming conventions are there to help you keep track of how your rooms are set up, how your PCs are set up. I mean, you don't want to name your PC. Okay, you got a secretary and you're just setting up her computer and you're like, oh, we'll make it Stephanie's PC. Well, Stephanie might get fired next week. Stephanie might go get another job next week. So now Cindy is working on Stephanie's PC, and it's not going to make sense for anyone who's coming in to say, I have a problem. It's showing up on my server that Stephanie's PC is broadcasting. Where do I find Stephanie's PC? And you're like, I don't know. We have a Cindy. So always make sure that that you make a better naming convention. We just talked about patches, upgrades, and rollbacks. So make sure that you have all that understood, and that anytime that you have to do a patch or an upgrade, whenever possible, please try to do it in a test environment. Okay. Whenever possible, for security purposes, okay, lock your server room door, security cameras, all that will come in handy. That concludes the podcast for today. I will please review, and then I will see you for the labs.